Hello and welcome back to my channel. Today in this video we are going to discuss next few questions from Feb-March 2021 paper 3 from 9709, that is Cambridge A-level mathematics. And here is the fifth question. A part: express root 7 sin x plus 2 cos x in the form r sine times x plus alpha. It is r sine together, where r is greater than 0 and alpha is between 0 and 90 degree. State the exact value of r and give alpha correct to 2 decimal places. So we need to change root 7. We are going to express it root 7 sine x plus 2 times cos x in the form of r times sine x plus alpha. Means it is going to be sine of a plus b, and we know sine of a plus b is sine a cos b and cos plus cos a sine b. So we can write it as sine x multiplied by root 7 plus cos x multiplied by 2, and we can equate it with, let's say it is going to be r, and here it is sine x cos alpha, because we can see the r is there, so r will be multiplied everywhere, plus again r cos x into sine alpha. So from here we can, otherwise also if you are very good with this, we can directly say, but that's fine, r sine alpha is 2 and r cos alpha, by comparing the term sine with sine x, it is r cos alpha, and here is root 7, so it would be root 7. So now we need to get r. So for r we have sine alpha and cos alpha, so let's square both the side and add it, so we'll get r square, and here we are going to get sine square alpha, here we are going to get cos square alpha. So adding both them, that is going to be 1 equals 2 square, that is 4, plus root 7 square is 7, so that is going to be 11, and hence r is root 11. That's the exact value of r. And for alpha we can divide both of them, so we'll get r sine alpha over r cos alpha, it would be 2 over root 7, and we can cancel r by r, and we got it as tan alpha. So tan alpha is 2 by root 7, and hence alpha is tangent inverse of 2 by root 7. And now this value from calculator, of course, 2 by root 7 is 37.086 and so on. We write our answer, it's given that our alpha correct to 2 decimal place, so 0 and 866, so it becomes 9. So alpha is 37.09 degree, and that's the answer. And here's the B part. Hence solve the equation this. So from the first part we have seen that root 7 sine x plus 2 cos x, we have expressed it as r sine x plus alpha, and r was root 11, and it was sine x plus alpha for the time being, because we have seen that alpha is 37 point, just a minute, let me, 37.09, so we will use it later. For the time being, let's write it as alpha. So in this case this is x, but here in this case it is 2 theta, so x is 2 theta, so we can compare it and we can write it as root 11 sine 2 theta plus alpha. everything would be same, only this x become 2 theta is equals 1. So we need to solve this. Sine 2 theta plus alpha equals 1 over root 11, and we have to be very careful that now till the time where our angle is 2 theta plus alpha, so we'll calculate 2 theta plus alpha every time. So 2 theta plus alpha is sine inverse of 1 over root 11, and let's calculate this. Sine inverse of 1 over root 11, this is 17.5484, so I'll write till 3 decimal place, 8 degree for now. And next angle, in the sine, the next angle we need to calculate till 180, so we can think of another angle as well for the time being. So let's say otherwise we can see it is 2 theta. For theta it is in between 0 to 180, so 2 theta would be, of course, it is going to be 0 to 360, so we have to check for other angles. So next angle, that is again angle is 2 theta plus alpha, is in the sine case it is 360. If one is 180 minus theta, so the next one would be 180 minus 17.548. so 180 minus this is going to be 162.45 degree, and again the next angle would be 2 theta plus alpha is going to be 360 plus this angle, that is 17.548. so 360 plus 17.548, it is coming 377.548. So now if we calculate any other angle, next angle would be 360 plus this, that would be of course more than this, so we have to calculate theta now from this. From the first one, from here, if we subtract alpha to get theta, it would be of course very less in the negative, so we only get our answer from these two. So let's calculate. Let's say it is first and it is second. So from the first we get 2 theta as 162.45 minus alpha, that is minus 37.09. 162.45 minus 37.09 is, from calculator it is coming 125.36. so we write our answer till 1 decimal place in the degree case, so it is 125.7 degree, and hence we get it as theta as 125 divided by 2, it is coming 62.68, so it means 62.7. We can see it is not the last answer, so we should write 36, not it was 36. I have written it as in the wrong way actually, so it is 36, only 125.36, and then theta is 125.36 divided by 2 and corrected to 1 decimal place, it is 62.7. and from the second we get 2 theta as 377.548 minus alpha, that is 37.09. so 377.548 minus 37.09, this value is coming 340.458, and hence the last theta divide by 2 is going to be theta, and it is 170.229, so it is 2 only, and that is the solution. I hope it is clear. Let's discuss the next one. And here is the question number 6. Let fx be 5a over 2x minus a times 3a minus x, where a is a positive constant. A is express fx in the partial fractions. So we have a product of two linear factors, we can see, so it is going to be written, we can write it as 5a over 2x minus a times 3a minus x in the form a upon the first linear factor, plus b over 3a minus x, another linear factor. So we'll simplify by multiplying both the side by this whole, multiplication by this 2x minus a, 3a minus x. We get left hand side as 5a, right hand side we get a times 3a minus x, because this is 2x minus a got cancelled when we multiply. Similarly from b we'll get only 2x minus a. So it is true for all the values of x, so we can replace x by any value. So first one, let's replace x by a by 2. Why? Because when we put a by 2 here, this would be vanished, so we can calculate a easily. So it becomes 5a equals a times 3a minus a by 2, 3a minus a by 2, it is a, plus b times x is a by 2, so 2 into a by 2 is a minus a, so we can see it is gone, 0. And here we got it as a, 3 2s are 6 minus 1, 5, so 5a upon 2, so we can cancel 5a one time, 5a one time, so we got a as 2. So we got a as 2. Now we can replace x by in order to make this as 0, so we can take it as x as 3a. So x as 3a, so we got it as 5a equals a times 3a minus 3a vanished, plus b times 3 into 2, 6a minus a, so it become again 5a times b. So we can cancel a, 5a, so we got b as 1. And hence the fx we can express it as a was 2, so 2 over 2x minus a, plus b is 1, so 1 over 3a minus x. And that's the partial fractions. And here's the b part. Hence show that integration from a to 2a fx dx is ln 6. So we are going to use our partial fraction in this case. We know that fx was, from the first part we got it as 2 over first one, that is 2x minus a, plus b, that is 1 over 3a minus x. So in order to integrate it, it means that we are going to integrate this. So we'll integrate it from a to 2a everywhere, a to 2a, a to 2a. So let's integrate. This is going to be 2 over 2x minus a. So if we integrate, we'll get ln times modulus 2x minus a, and divide by the differentiation of this, and the differentiation of this is 2, so we'll divide by 2, plus it is ln times 3a minus x, divide by the differentiation of this, and differentiation of this is minus 1, plus there is no constant, because constant of integration, because it's a definite integration. So we'll integrate between a to 2a. So these are the limits. 2 got cancelled with this 2, it become minus, and we can write it again ln times 2x minus a. We can remove this modulus, because we know that in between 2a to 2a it is going to be positive everywhere, upon, because it is minus, so log property, it would be division 3a minus x, a to 2a. So upper limit ln 2 times 2a, 4a minus a over 3a minus 2a, that is a, minus the lower limit. Lower limit is a, so 2 times a is 2a minus a over 2a minus a, 3a minus a is 2a. It is the lower limit. So we got it as ln 3a upon a, that is 3, minus ln 2a minus a is a upon 2, that is going to be 1 upon 2. And we can write it as ln 3 plus ln 2. If we take this, take the reciprocal 2, become in numerator 2 to the power minus 1, which will make it as plus 1. This minus become plus, and by the property it is going to be ln 3 to the 6, and hence proved. Otherwise also we could have written it like ln a minus b is ln a over b, so it is going to be ln 3 over 1 by 2, that is same as ln 6. And anyway we can write our answer. So I hope it is clear. Let's discuss the next question now. Here's the 7th question. The two lines have equations are 1, 3, 2, s times 2 minus 1, 3. R is 2, 1, 4, t times 1 minus 1, 4. And we need to show that the lines are skew. Lines are skew means not parallel and not intersecting. So this is what we have to prove. First thing is they are not parallel, because the parallel vector from the first line 2 minus 1 3 we cannot write in the as a product of factor 1 minus 1 4. So it means we can never write it. We can't find any case as that they are same. So it means lines are not parallel. And since this is a vector in 3-dimensional, so in 3-dimensional space we can see that two lines may not be parallel, but they are not intersecting, or they can intersect. There can be two possibilities. So we'll check for the next possibility that it is not intersecting. So if they are intersecting, it means there has to be some s and t for which both the lines are same. It means 1, 3, 2 plus s times this is going to be plus 2s minus s and plus 3s. This has to be same for some s and t, 2 plus t, 1 minus t, and 4 minus 4t. So if they are equal, then we have to prove that there does not exist any s or t so that they are equal. So let's get the three equations from here. From the first one we'll get 1 plus 2s equals 2 plus t, or we can write it as 2s minus t as 1. From the second one we got 3 minus s equals 1 minus t. So from here we can write it as s, I'll transfer here, and 1 this side, so it become s minus t equals 2. And from the last one we can write it as 2 plus 3s equals 4 minus 4t. So from here we got it as, we can write 3s plus 4t equals 4 minus 2, that is 2. So from the first two we'll solve the s and t, and we'll show that this is not satisfying the last one. So from the first one, first two, first, and this is 2 and this is third. So from first and 2 we add them, subtracting it, 1 minus 2 we get 2s minus s is s, minus t plus t is 0, become 1 minus 2 minus 1. So we got s as minus 1, and we replace minus 1 here, so we got it as minus 1 minus t as 2, so t become -1 -2, that is -3. Now we got s is -1 and -3. We'll replace here to check whether it is same as the right hand side is same as left hand side. And left hand side is 3 times -1 plus 4 times -3, that is going to be -3 minus 12, which is -15, which is not same as 2. It means there does not exist any s and t which satisfy both the equation. It means they are skewed, means lines are not intersecting, means lines are skew. So that is how we prove it. I hope it is clear. Let's discuss the next one now. And here's the B part. Find the acute angle between the directions of the two lines. So from the first part we can see the direction of the first line. So direction first line, I'm writing the directions. Directions for the first line was 2 -1 3, and the another one, the second one, it was 1 -1 and 4. This is given from the, we can take like r is a plus t times b, and this b is the direction vector. So from the first one it was 2 -1 3, and from the second one it is 1 -1 4. So these are the two vectors. We can write it as a vector as 2 -1 3, and b vector as 1 -1 4. And we know how to find the directions. We have the formula cos dot product. A dot b is modulus a vector modulus b vector and cosine of the angle between them. Let's say it is theta. So from here we get cos theta as a dot b over this. So let's find first of all a dot b. A dot b is 2 into 1 2 plus -1 into -1 1, and 3 into 4 is 12. So it becomes 12 plus 3 5 15, and modulus of a is square root of the square of their components and sum of it. So 4 plus 1 plus 9, 10 plus 4 14, and modulus of second vector is going to be square root of 1 plus 1 plus 4 4 just 16. So it becomes 16 plus 2 18. So from here we get cos theta as 15 over root 14 root 18, or theta is cosine inverse of this, which we will calculate from the calculator, and the answer is theta equals 19.1066 and so on. So we write our answer till 1 decimal place in the degree, and it is going to be 19.1 degree. That is the acute angle. So that's the answer, and that's it for this video. I hope it was of some help. Let's discuss the last few questions in the next video. Till then, thank you so much.